This is section 4.5, part B. All right, number 15. So whenever we have an equation with exponentials, one strategy that we like to use when we can is to have both sides using the same base. But in this case, we wouldn't be able to do that because there's no number we can use to, like 2 to some power equals 28 and 2 to some power equals 10. There's no number that's going to work that way. So in that case, what we're going to do is just take a log of both sides. It could be any log. So, the purpose of taking the log is just to be able to get the x's out of the exponent position. So in this case, since one of my bases is 10, I'm thinking I'm just going to use a log base 10 and apply that to both sides. All right, so I'm going to have log of 28 to the power of x equals log of 10 to the power of negative 3x. Alrighty, and then we're able to cancel out that's understood to be a log base 10, so that can cancel that out. So then we have log, and we're able to move this x to here. So now it's x times the log of 28 equals negative 3x. All right, so we would need to get all the x's to one side. So I would do that by adding 3x to both sides. Okay, so I have x times the log of 28 plus 3x is equal to 0. All right, now you could definitely not combine anything here. So this x is attached to the log and this 3x. So you couldn't like combine those or anything like that. But what you can do and what you're going to do is to factor out the x. Okay, so that's going to be x parentheses log of 28 plus 3. All right, and again, you cannot combine the 28 with the 3 because the 28 is stuck inside of that log. All right, equals 0. So now, in order to get x by itself, what we need to do is we need to divide both sides by what is in the parentheses. All right, so divide both sides by log of 28 plus 3. So 0 divided by anything is still 0. So our answer is going to be x equals 0. All right, for number 16, so we have a base of e. So I would start by taking the natural log of both sides. So that means I would have ln of e to the power of negative t equals ln of 0.04. All right, so I would be able to cancel out the ln with the e and just bring down negative t equals ln of 0.04. All right, so negative t is the same thing as negative 1t. So basically just divide both sides by negative 1. So that would just be t equals negative ln of 0.04. Okay. All right, number 17. Okay, So there's no way to write both sides using the same base, so I'm just going to start by applying a log to both sides. I'm going to go ahead and use the natural log. So I'm going to have ln of 5 to the power of x plus 2 equals ln of 4 to the power of 1 minus x. All right, and then I'm going to go ahead and move the exponents. All right, so that x plus 2 is going to be multiplied by the ln of 5. So I'm going to keep it in parentheses. Because the whole thing has to be multiplied by ln of 5. Okay, and we're going to move this exponent. So also it's going to be in parentheses 1 minus x times ln of 4. Okay, so now ln of 5 is really just a number. Same thing with ln of 4. So I'm going to distribute, okay, so that's going to be x ln 5 plus 2 ln 5 equals, and then I'm going to distribute, so that's going to be ln 4 minus x ln 4. All right, so now what we need to do is we need to have all of the terms that have an x with them over on the left side and the other terms that don't have an x over on the right side. So that means I'm going to add x ln 4 to both sides. And at the same time, I will go ahead and subtract 2 ln 5 from both sides. Okay, so all right, so that would leave me with x ln 5 plus x ln 4 equals ln 4 minus 2 ln 5. All right, so now on the left side, I'm going to factor out the x. So that will make it x parentheses ln 5 plus ln 4. And then I'll just bring the rest of this down. So that's equal to ln 4 minus 2 ln 5. Okay. All right, and then last but not least, I would divide both sides by what is in the parentheses. Which is ln 5 plus ln 4. All right, so my final answer is x equals ln 4 minus 2 ln 5 all over ln 5 plus ln 4. Okay, and you cannot cancel anything out because of the plus and the minus here. So, you know, those can't cancel. Nothing can really cancel. I mean, there's probably something you could do to, but you don't really need to do anything else. That would be a perfectly good final answer right there. Okay, so number 18, we want to solve for x. So in this case, we have some other letters hanging out in there, but that's not going to change anything as far as the way I'm going to solve it. So let's see. Well, I've got x is in the denominator right now, so first I need to not have it be in the denominator. So I'm going to multiply both sides by the denominator, which is ln of x. All right, and then so that would cancel out on the right side. All right, so let's just write that y as like a coefficient in front of the ln. So that would be y times the natural log of x equals w. All right, and we're trying to get x by itself, so the next thing I want to do is divide both sides by y. All right, so that would cancel that out here. So that would leave me with ln of x equals w over y. All right, and now to get rid of the natural log, I would use a base e, and that would allow me to cancel out this and that. So that would give me x equals e to the power of w over y. And there we have it. All right. And number 19, seemingly sort of random here. It says f of x equals e to the power of x plus 1 minus 2. Find f inverse of x and its domain and range. Okay, so remember that when we find the inverse, we're going to switch the x and y. So let's start by instead of f of x, we're going to replace that with y. It's the same thing. So y equals e to the power of x plus 1 minus 2. Then I'm going to switch the x and the y. So that's going to give me x is equal to e to the power of y plus 1 minus 2. All right, and now my goal is to solve for y. So the next thing I'm going to do is add 2 to both sides. So that makes it x plus 2 equals e to the power of y plus 1. Next, I would take the natural log of both sides. All right, and that would allow me to cancel out the ln with the e. Okay, so that gives me ln of x plus 2 equals y plus 1. All right, and I'm just trying to solve for y, so now I'm going to subtract 1 from both sides. All right, and you can't combine the 1 with the 2 or anything like that. Whoops, I went off my screen, didn't I? Sorry. Subtract 1 from both sides. Okay, and like I said, you can't combine the 1 with the 2 or anything like that because that 2 is all up inside of the log. So, all right, so what we can do is write down ln of x plus 2 minus 1. So the minus 1 is outside the parentheses. So that's equal to y, or in other words, that is equal to f inverse of x, okay? So that is my inverse function. And so the domain and range of that. All right, well, for the domain, we know that whatever is inside the parentheses must be greater than 0. So basically, x plus 2 has to be greater than, not equal to 0. So that means subtract 2 from both sides would give you x has to be greater than -2. So, in other words, the domain is going to be parentheses -2 to infinity. And then it's a log function, which means that the range is all real numbers. Alrighty. All right, and that is the end of 4.5.